Hello everyone, and welcome to this meetup, this Azure Security Meetup group. So thanks very much for joining us today. Um, for late morning for some of you, just mid-afternoon for some of you, and late evening like some of us for some of you. So thanks very much for joining us. So today we have an amazing session with Adin. Adin Ermie will be presenting today. And it's a very exciting topic. Adin will be speaking on injecting security into DevOps. Another way to put that is secure DevOps. So, and I'm excited about this because the first time that Adin spoke for a community group that I was a member of, it was amazing because he spoke on Terraform. So I'll let Adin introduce himself. So he's a 5-time Microsoft MVP. He's also a Terraform expert. So there's a lot of things to learn from him. So just a quick reminder, if you're yet to join our meetup group, the Azure Cloud Security Meetup group, please go ahead and use the URL that you're looking at on the screen to join the group. Also, just a quick thanks to our sponsors that make this possible. So Cavis Cloud Public Cloud Security and the Prisma Cloud provider, which is by Palo Alto Network. So thanks very much to the sponsors. But for now, I'm going to go ahead and hand you over to the capable hands of Adin to introduce himself and also to just take us through his session. So over to you, Adin. How are you doing?
Thanks, David. Appreciate you having me today.
No, thanks very much. It's a pleasure.
So let me just share my screen. You can make sure that you can see that.
Yes, we can see that. So I'll go ahead and add everything together.
Excellent. Okay, so welcome everyone. Thank you for taking the time today, whether it's morning or afternoon where I'm at, or evening where David's at, or really, really late if you're coming from a different time zone. Appreciate you taking some time. Today we're going to talk about security in DevOps, right? As David mentioned, also normally or commonly referred to as DevSecOps, but that's sometimes a little bit hard to say quickly. So secure DevOps is kind of the other way that people will say it. And we're going to focus on a lot of infrastructure as code. As David mentioned, I have a lot of experience with Terraform, so that's part of the flavor of our topic today, but we'll also talk about some other tools available. There we go. So we're going to first talk very, very briefly about why we need to think about security in DevOps or DevSecOps. And then we're going to get into some of the tools that I've used in various projects and teams, the results of those, what they do, kind of how to work with those, especially from a pipeline perspective. And then also we're going to talk about some other tools and provide some resources for everyone to kind of look at. So quickly, right off the bat, why do we need to do security in DevOps, right? Because really, there's no reason in deploying to production quickly if it's insecure. Just because we can automate things and get things deployed rapidly through like CI/CD pipelines, that's great. But if it's insecure, well, then we're having other problems to deal with in a more serious way. So these kind of memes kind of speak to that, right? Where do we do our testing, right? We always test our code in production. That's the key. But, you know, that's a bit of a misnomer, right? Because in theory, depending on how you're developing your code, you can actually legitimately test that in production. When you use things like feature flags or toggles for the code that you're developing, you can legitimately deploy that into production and then systematically test or evaluate that to be able to confirm that it works in the real world that it will be running for your customers. So we're going to dive into a handful of tools, like I mentioned. Now, in this case, it's filtered or kind of flavored around Terraform code or infrastructure as code perspective. Obviously, there's other tools available that we'll talk about later in different perspectives. So first and foremost, the first tool I want to bring to everyone's attention is Chekhov. Right? If you're not familiar with Chekhov, it was created by Bridgecrew, which is now owned by Palo Alto, right? But still the same great tool that they made available. This
Apologies
provides
for
us. Oh, yep.
interrupting, Adin. Sorry. I think we lost your screen sharing.
Oh, really?
So, yeah.
My apologies. That's
no
weird.
problems at
It
all.
still showed it was sharing. So let me try that one more time.
Yeah, it's coming up now. Yeah, there we go. We got it now.
Apologies. Yeah, that's kind of weird. Okay. Yeah, let me know if it drops again. That's interesting.
No problems.
Okay, sorry. Did you see the last slide?
Yes. So we saw the
Okay.
initial slide. Yes.
Perfect. Okay, so with checkoff, right, we get static code analysis for infrastructure as code, not just specifically around Terraform, right, but other infrastructure as code technologies, and it's a tool that the Bridge crew provides to the public to be able to use. So what do we get out of this specific tool set? Well, there's many different built-in policies, over 500 policies available that cover things like security within our code, compliance, best practices. Notice it scans like Terraform files or the plan files that you produce. It also has things against evaluating the provider settings and not just, say, the infrastructure as code code blocks that produce the resources, but the providers themselves, to make sure that is secure and compliant. It does things around evaluation of variables, so that when you are stringing things together or concatenating different pieces together to, say, formulate a naming convention, or you have variables that are passed in at the time of deployment for whether something is enabled or not, or configured or not. It can evaluate all of that. So it's not just effectively reading a static file and what the text effectively is. It's doing that evaluation part, which is great. It gives us a more accurate assessment. And it also supports inline suppression, right? So that if, say, we're developing some Terraform code, some infrastructure as code files, and we run it through this tool, we see that it's flagging something, say, hey, this is something you want to kind of look at, but you as a team or as an individual understand that maybe that's not quite 100% best practice, or you've mitigated that risk in a different way. So you can, in your code, actually add a line to suppress that from being flagged as a failure effectively on the scan, and allow your pipeline to continue in that process. So lots of little enhancements and lots of really good features around this. Now, when you go and look up checkoff by Bridge Crew on the GitHub page, right, there's lots of examples of how to use it, how to run it, say, in like a pipeline, or how to run it in like a Docker container, which we'll do in a moment. But there's also a new version coming out. I think next month is when it's coming out. I don't know exactly when. I don't work for them, but they have made an announcement that they're working on like the next version of checkoff, which has improved performance, hundreds of additional scans and policies built in, and so forth. So they're really contributing quite a lot back to the community in providing this type of tool and further enhancements for that. So that's really great to see. So when I worked with it, at the time of my working with this specific tool, what was good? What did I like about it? Well, first and foremost, right, there's lots of different checks like you see here. It checks against all the major cloud providers, right? Some have more, some have less. And that's really as they iterate and add more additional checks to that, you can contribute back to that too. Let's say there's a check in GCP that you want to have in there that's not created yet. You can go through the process and build that out and contribute that back to the community, back into the tool, and then everyone can benefit from that. It also checks Kubernetes because everyone uses Kubernetes now, right? That's the big thing. And the other really good thing that I like about it is that you can run it as a Docker container. So depending on your DevOps approach and process, you may or may not be allowed from a pipeline perspective to install, frameworks and tools and utilities within your build agents. Some environments have a more restrictive kind of space to play in. So being able to effectively encapsulate checkoff into a container and run all the scans and the tools and the processes that it runs within a Docker container, and then throwing that away once the scans are done. It's clean, right? Super clean. You don't have to worry about anything kind of being residual, right, left on the build server, anything like that. Now, not everything, of course, is always green. There's always sometimes a little bit red, some things that are not quite good. So one thing that I found in my use of this tool is, depending on the code that you're scanning, and I'm going to maybe reference specific to Terraform in my case, if there's an issue where in your Terraform code it's trying to maybe reference a module that it can't resolve or something to that effect, in the output in the console, and therefore in the output when you're capturing the results of that, it'll say, warning, it'll have these warnings, and that's fine in the console, but that causes problems if you're trying to capture this output and then use it in an Azure DevOps pipeline to publish it as test results or pipeline results. So that's an issue that I ran into with that a few times, but thankfully, working directly with the bridge crew and the checkoff team, directly showing them what I was trying to do, the approach I was going about it, the results I was getting, we were able to actually figure out where the problem was and make a change either to the public documentation on how to run the proper commands for the Docker container to work properly, and then also what I needed to change, say, on my Terraform code to be able to get the results expected. So that in itself is a great testimony to the team being willing and able to work with the community to further enhance and improve the product. So let's pop out of the deck and let's kind of see this in action. So just give me 1 second here. So if you can just confirm you can still see my screen there, David?
Yes, we can see your screen.
Perfect. It didn't drop. Excellent. Okay, so here I'm in my Azure DevOps org here, and I have my pipeline specifically for Terraform and to run checkoff. So I'm going to kick this off real quick so that once it initializes, we can kind of walk through and see what it produces, how it works, and see the results and how we can kind of action those results from a pipeline perspective. So as this just starts to run, think about it from the perspective of the ops team, the infrastructure team. You're writing your templates to produce this environment. You would want to run a tool like this, and really all the tools that we're going to talk about today, as kind of that quality layer or that quality check, right? Before it, say, is allowed to be committed back into the master or main branch and then executed against production. That way, we're ensuring we're evaluating and testing our templates from a security or compliance perspective and ensure that it passes so that we can then allow the rest of the pipeline to actually execute and deploy. So here, while this is just finishing up, I'm going to jump to the top of this output here. So here it shows us, what version we're running in case we run into a specific issue and need to target a specific version. And then it starts to spit out all of our results. So we see how many checks were passed, how many were failed, and then if any potentially were skipped. So I've targeted a directory that has a mix of AWS Terraform and Azure Terraform code in here. So you'll see there's going to be a mix of AWS and Azure outputs, but we see here's the rule, right? Here's what it's trying to kind of look or check for. And, this one passed, and that's great, but let's kind of jump down and find one that failed. There's going to be one at the bottom. So that's GCP. Here's a better example. So here's a GCP one. Again, this one failed. Here's the resource specifically that failed, and then where in what file, so in this specific Terraform file, on what lines of code is the failure. So this is that code block that it evaluated, and it's saying, hey, there's an issue, it doesn't align to this or that. And it even gives you this guidance for this specific rule. So if we click on that and open it up, it'll bring us to their kind of knowledge base or documentation to explain what does this do, what is it checking, how do we fix it, that type of thing. So it gives us a lot of great guidance. Whoops, wrong screen. A lot of great guidance here to be able to dig into the check of our code from a security standpoint, and then not only just say, hey, you did something wrong or something's not secure, but giving you that guidance on what you might need to do to correct that. So what we've also done in this pipeline here is we've ran the scan. So red is good in this case because we expect it to fail. And then we're publishing the artifact because I just want to grab the artifacts that are produced out of this and publishing the test results. So if we go to the root here, we see under published, here's that output XML file from the report. So maybe I have to download it and send it to security directly, or we want to archive this for some purpose or need. We have that available in the pipeline to reference. And then in the test, we see here's all of those test outputs that it told us, right? How many passed, how many failed, and others that would be like skipped in that case. And we see all of this output underneath. Now it's a little maybe hard to see. I'll collapse some of this here. So we see all of those rules that failed, right? It doesn't list by default all the ones that passed because then it would be a longer list, but you can toggle that. And here's the ones that we need to kind of focus on. So if we choose something in AKS, if we click on that, collapse this a little bit, again, it provides us, this is the specific information of what failed, so this specific resource. Some will provide additional information on like the lines and so forth. It depends on kind of how it publishes that XML file. Now, if you wanted to say, look at the rest of the output, not just the failed ones, see, we only have 127, you would just change that here. We can clear all these markers, and now you can see everything that did specifically pass in that scan. So we get everything all in kind of one big shot, which is excellent. We get, how much is passing, and as we rerun this over and over again in our pipeline, you'll have whether it goes up or goes down from a trending perspective on if you're improving or not. One last quick thing on the summary tab here, under tests and coverage, it also populates and shows the percentage based on the results that we get out of that. Okay, let's flip back over to see if there's any questions. I don't see any, so we're good so far. Let's talk about the next tool. So the next tool is TFSec, so Terraform Security, effectively. This does a static analysis of your templates specifically around security issues. So you'll see in some of these tools, or a lot of these tools, there may be a little bit of overlap, and one might catch certain things that another tool might not. So there's no one tool to kind of rule them all, or only one tool to run as part of a secure DevOps approach from infrastructure as code. It's generally recommended you find a tool that works for you, for your security needs or the security team's requirements, and be able to enact that in your pipelines. So what do we get out of TFSec? Well, similarly to the other tool, we have checks for sensitive data. We have violations and security best practice recommendations. One nice thing about TFSec is that it scans modules, right? Now, it only targets what's local and not, say, if you're referencing a module from the Terraform registry, for example. But scanning modules is nice because that's a better way to build our Terraform code, so that they're like Lego blocks, and we're just calling the one block when we need it and not have one giant Terraform template to debug and troubleshoot. Now, it also evaluates expressions. So instead of, again, just reading like plain text from the Terraform template itself, when we have variables that are passed in or the functions that are passed in to build different properties, it's going to evaluate and resolve those so that we can get, again, a more fuller review versus effectively gaps in the assessment, right? Because if it could not evaluate the expression, if we say we're passing in a true or false, or we're passing in a specific property or parameter or value, right? If we can't evaluate that, then the result will kind of be mixed. We won't, it might be a false sense of security, right? So with this, what did I like out of this tool? Similarly, it has checks for all the top public cloud providers, right? Some are more than others. It also has some general checks that they've built around just in generality, which is great. So again, not just focused on one technology, not just focused on one cloud. And like the other tool, it runs in a Docker container, which is awesome. What's not so great in working with TFSec is that, as we'll see in the demo, it does not include the past test results in the output. You may see them say on the console output as far as on the screen, but it doesn't produce that in a way that you can capture that into the output to publish it as a test result in the pipeline itself. Now, one other thing that has come up that another individual brought to my attention after they read my blog post about it is around custom rules. So there's some default rules, obviously all these checks that are here, but if you wanted to build a custom rule, you can do that and run TFSec and use that custom rule. And that's okay from the perspective of if you're downloading the executable or you're building the package and then you're injecting that. But when you're executing it as a Docker container, which again is a cleaner way to execute it on, there were some challenges to get custom rules into that so TFSec would look at those other rules. So that's maybe a bit of a gap that you might have to explore. If you might have to rebuild the container, for example, and inject your custom rules before executing it versus maybe passing it directly in, like mounting the volume into the container, for example, to where the rules are sitting. Okay, so let's see how this one works. We'll go back to our pipelines. Under infrastructure, and we're going TFSec, and we will run this. Okay, so now while this is running, we'll see. I like the output of this from a human standpoint, from a human readability standpoint. Even though you don't have to have obviously color in the output on the console, it makes it easier to read or consume. From a human being perspective, it kind of really draws your attention to when there's an issue or when there's like an error versus a warning, as you will see in a moment. Not required, of course, because we're going to take those results and push them into the pipeline test results anyways. But if, say, someone wanted to look at and watch the pipeline execute itself, then it makes it a little bit nicer. So again, I'm going to jump all the way to the top real quick here. So here's where if we have those warnings like I was talking about, if we have something like this where it spits out a warning because it couldn't find or load a module when it's doing that module evaluation, this may surface itself into the XML file in publishing the results, and that could cause an issue where the results won't work. It won't be able to publish because it's not finding the pattern it's expecting. So that's one thing to kind of be aware of. But we see here really nice, really nice visual, right? Clean and easy to see. Problem 1, problem 2, what it's targeting, right? Azure, GCP, right? So that's really good. And then also warning versus error, right? So it's very clear if you're going to look at this output in the console from the pipeline, very easy to see that, okay, what cloud am I targeting? Is this a serious issue or maybe something we want to look at later? Where's the file that it found it in? where's the code block it found it in. And just like the other tool, it also has a link for more information on, hey, if you hit this, what do you need to do? Here's an insecure example. This might be a little small. My apologies. Make that bigger, right? Here's an insecure example. Here's a secure example, right? So again, it provides you, keep hitting the wrong tab. It provides you with that guidance instead of just saying, hey, you did it wrong, or hey, this is unsecure, and have fun figuring out how to make it work properly. It gives you that guidance. So that's a really nice a feature that we get when we're trying to, say, scan a large repo. Maybe we're just getting used to infrastructure as code, so we're not too sure. It really helps us to learn those best practices, those secure practices, and be able to apply that to what we do. So at the bottom of the output, in this case, it shows us, how fast it took to run, but basically how many potential problems were detected. It doesn't say how many it skipped or how many were passed, but potential issues that we may need to address. So similarly, just like the other one, if we flip back in here, we have the exact same type of concept. We have the output XML report that we can grab the artifact if we need to. It has a 0 pass here because remember, we said it does not include the number of tests passed. So it might not actually be 0, but from a TFSec perspective, it's 0 because all of the, if there's one failed test, then it fails effectively. So that's just something that could kind of throw you off a little bit, especially if you're going to use this for like a security audit, for example, or some type of security report. That's something you're going to want to just be aware of, because even if we clear this out here, we see that the number here still stays at 10 because it's only produces the failed results, not the other, which would be skipped. And then more importantly, in my opinion, knowing how many passed, because if this is 10 out of 11, that's a bigger deal than say 10 out of 1,000, right? Obviously, they're still important to address, but it gives you a better perspective on knowing that for the most part, or a majority of your code is good, and there's just maybe a handful of things that need to be addressed. Right. So I did bring that up to the authors of TFSec. There is I believe there's a pull request in their GitHub repo around adding that. I think someone maybe was working on trying to add that or at least start a thread. So if you choose to use this tool, maybe go and chime in on that pull request or that issue that was posted, so that we can get more traction behind that, because I think that's one of the bigger kind of needs to really understand how well you are doing from a security perspective for your Terraform code. And just like the other one, right, it spits out the error message. Let me collapse some of this a little bit here, but here's that error that we got, and then here's that stack trace, specifically what file, what lines, and here you go. You could kind of get the same output that we got from the console, not with the colors, but that's okay. We still collect that information. Okay, just checking if there's any questions. Nope, good. Okay, so let's go back and continue with the next tool. The GitHub Super Linter. Now, this is designed, if I just quickly go to the next slide, this is actually an interesting tool because it's a one-to-many. There's a multitude of linters inside this kind of linting tool. At last count, as it ever changes, there were 43 different linters inside the GitHub Super Linter, and it helps to validate our code, right? Check for broken code, establish best practices, that type of thing. Not necessarily purely security focused, but it's still a good or best practice to do linting on your code. That developers do linting on their code from an application perspective. We can still follow the same type of practice on the infrastructure side with our infrastructure as code as well. Now, keep in mind that there's 43 linters inside this tool. We are not going to talk about every single one of those 43 linters. We're going to talk about 2 of them specifically around Terraform. Now, there's actually 3, but the 2 that I have in this example is TF-Lint and TerraScan. So they work kind of similarly, right? Where they look for errors, illegal instance types. TF-Lint is actually really good for that. There's many different rules for the different cloud providers. One thing I really like about TF-Lint is that deprecated syntax, right? Just like we get maybe when we're just running Terraform in general with Terraform init, and it tells you, hey, this syntax is deprecated and it's eventually going to be removed and not work anymore because it's not going to exist. You might want to change or update your Terraform code to align to whatever the new syntax is before we rip it out, right? So getting that up front even before doing Terraform init is a really nice feature so that we can kind of be ahead of the game, right? We can make the changes before, whatever the next version of Terraform releases, where that syntax will no longer be available, and then all our Terraform templates would break. TerraScan also has many different policies focusing around security, obviously, in our conversations today, but it's not just Terraform. It checks against Kubernetes, against Helm, right? Those types of things, against GitHub for its support. Lots of feature functionality, and it's not just a Terraform only tool, even though it's labeled as Terra in the beginning of it. So really good a tool set that we can use here. Now, what I like about the linter, the GitHub linter, is that there's 43 linters all in one. So you run GitHub super linter and you get linting for literally everything. Obviously, I don't have an exhaustive list here on the screen, but you can either say, hey, run all 43, or just run these 2, these 3, whatever you kind of want to do, subjective to what your environment is, what code you're scanning, and what you're kind of targeting, right? Now, the third one that I don't have an example for is Terra Grunt. If you're familiar with that, it can also lint those files too. So it's great. However, on the not good side, the GitHub linter produces the results, the report results from its scans in a format called TAP, a TAP format, which is fine. It's more universal. But if you want to take the output or the results from the linter and, again, publish them as a pipeline test result, you're going to have to do a little bit more legwork. You're going to have to take each TAP file that's produced, which I'll show you in a moment, and then parse and convert it into a format that is supported in, say, Azure DevOps for the pipeline test results, which has a specific format that it supports. So JUnit, XUnit, and so forth. So not too big of a deal per se, but it does mean you're going to have a little bit more work to be able to utilize the results from within the pipeline realm or space. Now, one other thing not good that I didn't put on here because it's hopefully only temporarily not good. Unfortunately, lately, the last couple of weeks or so, the GitHub linter has not been working for me. So every time I run the linter, it fails to recognize the directory as a Git repo and doesn't find any files in it. So it's something I think is a little bit off, and I'm going to point the finger slightly at the GitHub linter because I've tested it in Azure DevOps and also the GitHub Actions functionality for it too. So in 2 separate realms or spaces and tool sets, and it produces the same broken error. So I think there's something kind of off somewhere. So just be aware that if you go to look at it and start to play with it and it's not working, it's might not be you, it might actually be the linter. So I do see, just real quick, I do see there's a question about, can we customize any of the checks that the tools look for, and how easy is it to do that? So excellent question. So yes, you can customize, like from TFSec, checkoff, the linter. You can control, if you look at the GitHub repo that it's on, you can control which linters it runs, for example. So yeah, it's not just set in stone. You can make modifications. Some of them you can do inline changes in the code to remove false positives and things like that. Yeah, good question. As far as how easy, that's it depends, or it's subjective answer, because it depends on the tool. It depends on what exactly you're trying to do, right? And if it's kind of supported, if you have to modify code versus just passing in a parameter, right? It kind of depends a little bit there, but good question. Okay, so let's see. I'll call it a demo, but we're gonna play the cooking show here, and I'm going to actually bring up the one time that it worked for me, like 2 months ago, so that I at least have something to show for you all today. So here, even though it's green, ignore that, and even though it says check off, I was copying and pasting my Terraform, my pipeline framework, so ignore that. It is the linter. Here it downloads the container, the Docker container, and off it goes, right? So there's a lot of stuff kind of sitting in here, and it will effectively go through, and when it finds any files, it checks the file types, and then that will tell the linter itself, unless you explicitly tell it when you're calling it, what linting to do. So here, this linter specifically is for checking for copy and paste issues, and it kind of runs through everything one linter at a time. If we scroll down a little bit more, now it starts to run the markdown linter, because I found markdown files, and off it goes, right? And then here's where we get to the Terraform stuff. So it's found my Terraform files. So the first thing it's going to run is tflint and iterate and loop through all of the files that I have there. If I scroll down. And then the next one is terrascan, right? Same type of thing or process. And here's where it'll start to spit out and say, hey, terrascan, in this case, not tflint, found some issues. Here's what it's showing, right? Here's the rule that they have within there in the description that they're to help you know what is actually evaluating, what file it found this violation or this potential issue in, right? What I called the resource, what resource type, and what line it's actually on. So it doesn't actually show the code output, right? The code snippet, but at least gives you this direction to say, hey, it's in this file, it's on this line, this is the resource that you call, like this is what you called it, and this is the issue, right? So it's still pretty good that way, aside from the current issues with it potentially breaking currently, but that's okay. And it basically loops through everything all the way through all the different linters based on the type of files that it finds. And at the end, we'll see here, it creates this superlinter.report directory. And within there, it produces a tap file for every linter that ran subjective to what it found, like in your code base, right? So obviously this isn't 43 different ones. It won't necessarily produce empty files, right? But if it ran a linter and it found something, it's going to create this tap file. And this tap file is the object then we need to do that conversion on, so that we can publish it in the results. So that's why I have a conversion step here that goes and grabs the tap file in that directory. Here I'm just explicitly saying go grab the terrascan and tflint one, so that, because that's what I'm working on. And it's using a little utility called tap JUnit, which will convert the tap file into JUnit format, which is supported for the pipeline execution. Now, when you do this conversion, I need to produce an XML file that's in JUnit format and then publish the actual results to the pipeline. So if we jump back to the execution, we see we have two published files. We have one where I'm collecting all of the tap files directly. So these are the raw outputs from the Github Linter in case I want to download and look at those directly for any purpose. And then when I convert the ones that I'm interested in, I also make on the fly a separate directory to capture the converted files. Again, if I ever have to download or archive or use those raw outputs directly. And then we get the coverage, again, just like the other tools that we have there. And if we go in the tests, we see it includes pass, it includes failed for each of this. So if I clear some of this out and maybe minimize this and collapse. So we see we have the GitHub Linter tflint, 35 passed. Here's all of those outputs, just so we have that reference. And then for TerraScan, same thing, right? All 35. It's saying 35 because we haven't cleared it to say just show me the failed, which is 4. So I'm just checking that I do see another question about, does any of the tools fix the issues detected, maybe using a pull request, or do they just detect issues? So excellent question as well. So the tools themselves do not fix the issues. There are other tools, specifically say if you're using a GitHub repo versus say an Azure DevOps repo, and the GitHub like Dependabot or the GitHub security tools will actually kind of do that automated action where it'll say, hey, I detected this and here's the fix, and create a PR for you to review for that change. So not every tool does that, but some of the more AI and machine learning based ones in GitHub itself do have that functionality. But good question. These are more just, hey, scan my code, scan my templates, and let me see the results, and let me as a human being react to that and decide what I want to do. Like, do I want to correct the issue? Do I want to like suppress it as a false positive or an accepted risk for my team or my project? Right? It can't intelligently make that decision for you per se, right? Okay, now let's talk about the last tool here, which is Terraform Compliance. So this tool is obviously in the name about compliance, but it's actually a little bit unique and specific around how the framework works for this. So just to kind of give you an idea here, Terraform Compliance uses something called behavior-driven development, BDD, and it focuses on negative testing instead of just scanning for certain things. So it's actually a little bit different of approach. If you're familiar with HashiCorp Sentinel, it's similar to that, but it's only specifically for Terraform. It's open source, so obviously HashiCorp Sentinel has a cost involved to it, and there's a testing framework around building policies that will then be used as part of the scan. So what I liked about that, and you'll see, is that the output we get from Terraform Compliance, very clear, very easy to understand as a human reading the output. It can run in a Docker container as well, which is, again, extra bonus, makes it easy to clean up after the fact. However, we'll get to the star point in 2 seconds. The not so good is the learning curve to learn that BDD framework, the behavioral driven development process. That was completely new to me when I looked at it, and very honestly, I struggled with wrapping my head around the concepts. Like, from a readability standpoint, okay, it made sense, but it wasn't clearly explained how to work with that framework and that approach in developing your own, say, custom compliance checks. And that threw me off for a bit. The other thing is that Terraform Compliance requires that you have a Terraform plan file. Now that's a key point that's different from the other tools we've reviewed, because to produce a Terraform plan file, you need to run Terraform init, which means your execution in the pipeline needs to be able to communicate to the cloud environment or whatever environment you're targeting for Terraform. Whereas the other tools don't need that. They just say, give me your Terraform template code and we will scan it as is. This tool requires you to do a few extra steps, not too big of a deal, but it's a bit of an extra thing you need to think about from a pipeline perspective and DevOps, because maybe you don't want to yet do that as part of a quality check, for example. So just keep that in mind if you're going to start to explore the Terraform Compliance tool. Now, tied back to the learning curve of BDD, there were limited examples of how to work with that. And that's also what threw me off in trying to understand, how do I make my own compliance rule? Where does it have to be? What format it needs to be in? That type of thing. So more examples would be ideal. If you work with this tool and you come up with a few other examples, maybe specific to a certain cloud provider, a specific type of resource, or even like an industry perspective, please do consider contributing them back to the community, right? Scrub them where you need to, but contribute back to the community so we have more examples to read from and be able to help other people learn to build these compliance rules. Now, the kind of point at the bottom of the screen that there's no control over the Terraform version. This was a bit of a rude awakening when I was running through this tool, because I had Terraform, a certain version of Terraform I was using in the pipeline. And when I went to run this tool and I produced the Terraform plan file and then gave the plan file to Terraform Compliance, it then said, oh, I don't like that. It's not in a version of Terraform or produced by a version of Terraform that I'm expecting. I expect, version, say 14 dot whatever. So it's like, okay. So I went and reran it and changed the version of Terraform that created the plan file and made it to the latest. Give me the latest version, say 14.4. Gave it over to Terraform Compliance, and it still complained. It's like, oh, I don't like that. That's in a newer version of Terraform that I don't have. So that's one kind of piece of feedback I gave to the author or creator of this tool, that in the documentation, it is not clearly stated what version of Terraform this tool is using, nor does it give us the ability to control what version of Terraform it should be executing with. And the challenge with that, if you read my blog post on this specific tool, is that it will, you may be using an older version of Terraform, but need to use a newer version of Terraform to create the plan file that this tool needs. But you might not be ready to upgrade to that version of Terraform. Or the reverse, where you've written Terraform and it's been executed against the latest version, but now you have to backtrack to an older version just to run this tool. So that can be a little bit of a challenge that you want to kind of keep in mind. So before we jump to the demo on this, I saw a few questions in the chat. So there was one about, do we need to do the process in every stage? So like, I'm assuming like running the scans and so forth for like dev, pre-prod. So that is subjective to how you are going to run your execution of Terraform itself, right? Are you going to have a quote unquote build stage where you produce your plan file that's applicable to each environment and store that as an artifact. And then when you get to deploy to dev, QA, test, production, then you're actually referencing the actual just the plan file that was originally effectively snapshot against whatever you did in the code. So you don't necessarily have to run the process at every stage. It's more, these tools are more that pre-build and pre-deploy security and quality checks. So there's another question on which static security tool is the most comprehensive for assessing Azure RM Terraform code. So, well, there's a difference between ARM and Terraform code for sure, and Terraform effectively translates the Terraform template into ARM and passes it to the Azure API. But most comprehensive is a little bit subjective, right? Against what? Are we talking like certain security things, like that we have the most flexibility to create our own rules around that? Or so that's a little bit subjective. Another quick question about what do you think of Azure policy usage in pipelines? Can it be combined for all of these tools? Yes, excellent question. So Azure policy for sure is definitely applicable in a pipeline as a compliance check as well from the resources that you're attempting to deploy. But these tools happen before that, right? I see I got 5 minutes left, so let me just quickly jump to the demo to get that running for Terraform Compliance. Wrong one. While I talk, I'll stick around at the end. We can discuss that, the policy piece after. Okay, Terraform Compliance. Let's give this a run. Okay, so while we wait for this to go, yeah, policy would be more you're actually executing the deployment of it. You're attempting that deployment, and Azure policy will block it because it doesn't comply. Whereas these tools are more you're evaluating your template code before it's actually triggering a deployment, for example. Okay, so it's pulling down the container. Come on, internet. And any moment now, we should get a bunch of output. There we go. Perfect. So we'll see if I, again, quickly jump up to the top where it starts its execution. Right here, right? It starts to run its tests. We're telling it the features, that's effectively the policies it's using to evaluate. So you can point it to like wherever you may have your own features stored, and then off it goes. It's saying, okay, this is skipped, gives you more details on what it's doing. And then at the end, real quick, we have our one that failed. So we see it's really easy to read as a human being, right? The feature, it tells us what it is. It's a description. This is related to storage. Our scenario is if we have a storage account, right? We want to ensure that secure transfer required is set to enabled. So the BDD method is literally this human readable way of declaring or defining that. Given I have an Azure storage account, it must have this property, and that property's value must be true. Super clean, clear from a human standpoint to read and to write. And then it tells you here as the result that it failed because it didn't match that. So we have these results spit out at the bottom, and exact same thing like we were talking about before. We can grab the artifact report from there. We get the coverage. Now it's set to 0, even though there were some that were skipped. But if we look at the tests, we see 61 were skipped, 1 failed, and 0 passed because I narrowed the scope to make it faster. And then here's our compliance that failed. Same type of output that we got. Okay, let's wrap things up real quick for everybody. Just a quick comment on a couple other tools, because we've been focused on Terraform and infrastructure as code predominantly in our conversation today. But that's just one piece of the pie, right? There's always more than one way to do everything. So there's different tools out in the market. There's many out there. Some of them you may have heard of. Some of them you may have not heard of, right? OWASP, very common. White Source, Sonar Cloud, very common. But then other things like, Aqua, Trivy, Sneak for scanning container images, right? Detecting secrets with Yelp or Anchor or Trufflehog, right? And then open source tools provided by things like Checkmark or GitHub Advanced Security. That's the one we're talking about, where it will detect like an issue in the code, but then submit like a PR to fix it, right, for you, so you can review it. Shift left scan. There's lots of different tools out there, and if you happen to kind of see or take note in my repo in Azure DevOps, I'm actually working on a demo for a lot of these individualized pipelines for these different tools, really to assess and evaluate, does it work? How does it work? How hard is it to make it work, right? And get output and the results that we want to produce and share, and then being able to use it even for demos. So let's kind of wrap things up real quick and easy with some resources. I see that some have been sharing my blog post on these, so that's perfect. Thank you very much for sharing that. These are the articles I've written specifically around Azure DevOps, not the GitHub Actions. I'm working on those as well as part of a demo. But with these different tools, not only executing the tool in the pipeline like we demoed, but then what you have to go through to get the proper output in the right format and then publish that as a pipeline test result back into Azure DevOps, right? Because you can get the output to the console, but if you want it nice and fancy with some graphs type of thing, there's some other things you need to do on these various tools like we were discussing. So with that, this is who I am. For those that are aware or not aware of who I am and what I do, I work for Microsoft. I'm a cloud solution architect specializing in Azure infrastructure, among many other things on this list. Obviously, like we've been talking about today, infrastructure as code. So ARM, our new bicep language, Terraform, obviously from our conversation today, and some of the things I've been accredited with. And all my contact information is there so that you can either connect with me on LinkedIn or Twitter, check out those articles I wrote on my blog for those different tools. I have lots of code samples of Terraform on my GitHub repo, and some YouTube videos on Terraform basics and Terraform Advanced and Terraform DevOps, among other things. So with that, I'll leave this up. I'll stick around. I've got time. I can stick around for additional questions that maybe weren't answered.
No, that was absolutely awesome. Thanks very much for that, Adin. So definitely got some very useful pointers there. And I also like the style that you followed, which was you didn't just talk about the good points about these tools, but also like some of the challenges that that you saw when you used them. So that was very useful. So thanks very much for that. So so ladies and gentlemen, so you already know, so that's Adin's contact information on the screen. So if you do want to, I highly recommend that you do connect with Adin. So his Twitter account is also posted in the chat window. So do connect with him on Twitter, on LinkedIn, and other platforms. So we also have in the background working here, helping us out. So we have Ibrahima, who's been very helpful to the community. So thanks very much, Ibrahima, for doing this and for helping out. So if you're yet to join our Meetup group, please make sure that you use the URL that we posted earlier to join the Meetup group. And also the recording is going to go live and up on YouTube after this. So thanks very much, ladies and gentlemen. If you have any question, feel free to post for Adin and we get to that. But otherwise, thanks very much again. And we'll see you in the next Meetup on Azure Security. Have a lovely day, afternoon, evening.
Thanks, David, for having me. I do see there's one other quick question there that came in about whether we can expect a DevOps toolkit like the AZSK for Terraform. Well, that would be maybe a question for HashiCorp and not for Microsoft, because Microsoft does not own Terraform, but we do obviously have our own Azure SK toolkit, right, which is also in the works of being updated as well. So that might be something if you have any contacts in HashiCorp. I haven't seen or heard of anything, but that would be really cool if we had a toolkit like that too.
Okay, I'll go ahead and end the live meeting now.